today's lesson, complete the square. We've been working with ellipses, okay? So complete the square is something we've done before with back in Algebra 1. I taught you earlier this year as a refresher, and then we used it on circles last week, and now we're going to use it again for ellipses because sometimes the equation is just given to you as a conic form, which is this big, long equation. You're like, oh, what does that even mean? So you have to know how to manipulate and organize the numbers and complete the square so you can put it into the standard form, which is this right up here. Here are the steps for today. Move all constants to the right is always the first step. You want to organize each set of x and y terms, complete the square. If it's possible, factor and simplify. And then, of course, this bottom equation is what it's supposed to look like at the very end here. Okay? So I'm going to do a couple problems. Number 1 will be easier than number 2. Number 1 there's a focus on number 1, and then number 2 will show you a more difficult problem. Okay. So number 1, let's just focus on number 1. X squared plus 4y squared minus 100 is equal to 0. It's not in standard form, so I want to always start with my constants. There's negative 100 here on the left side. You always move all your constants to the right side of the equation. So negative 100. The opposite of negative 100 is add 100 on both sides. Okay, when I do that, now I'm going to organize my x's and my y's. We have x squared. We're going to bring that down. I'm going to see if there's any other x's I could bring down. There aren't. And then I'm going to bring down my y's. We have positive 4y squared. See if there are any other y's to bring down. There aren't. Negative 100 plus 100 cancels out, which is equal to 0 plus 100, which is equal to 100. Okay. Now, at this point, I want to complete the square on the left if my terms are not, or if they're not perfect squares. So looking at my x's, all my x's are together, and they're actually already a perfect square. X squared by itself is a perfect square, so I don't need to complete the square. 4y squared is all together. All my y's are together. There's only 4y squared, and 4y squared is also a perfect square, right? So we could get a square root of that. So I don't need to complete the square here. However, my coefficients are different. I know this is not a circle because this coefficient in front of the x is a 1, and then the 4 here is, these are different. So here's your hint that this is not a circle. Since it's not a circle, looking at my standard form of the equation, I know everything has to be equal to 1, and right here everything is equal to 100. So looking at this number, I don't want it to be equal to 100, I want it to be equal to 1. So how do I make this number equal to 1? I need to divide everything by this particular number. Here's the first thing you need to see. So to get this number to be equal to 1, you divide it by that particular number, which is 100 in this case, and you're going to divide every term by that number. Actually, I'm going to back so I can play it. Okay, so we're going to divide this by 100, which is going to be equal to 1, x squared by 100, and 4y squared by 100. Left side, can I simplify x squared over 100? Nope, we're going to bring that down here. And then the y squared term, we know that 4 goes into both 4 and 100. 4 goes into 4 once. It goes into 125 times. So we bring y squared down over 25. And then it's almost in standard form. This is an acceptable answer. We could use that. However, if we want to include h and k, in this case it's 0, 0. We just place markers for those. So x minus 0 squared over 100 plus y minus 0 squared over 25 is all equal to 1. And that's how you do number 1. Okay? Now it's in standard form. I know my h and k is 0, 0. A squared is 100, so a is 10, b is 5, and that's it. We can use that to graph. Okay, that's number 1. So the major step here is right here. Why did I divide by 100? So I'm going to put an asterisk by here so that you see that, okay? This is where I want you to put an asterisk for yourself, okay? We got 2 more steps or 2 more concepts we need to get through. So number 2 looks a little bit harder, right? So we got 7x squared plus 17y squared plus 112x plus 102y plus 6 is equal to 0. Always start with the first step. Are there any constants here? Yeah, there's positive 6. The opposite of positive 6 is minus 6. Okay? So we got 7. We're going to subtract 6 on both sides, and we're going to organize all my x's together. So we start with the biggest exponent, so it's 7x squared. bring down the positive 112x. Leave it a little space to complete the square. Then we're going to bring down the y's. We have 17y squared plus 102y. Bring down a little, keep a little space to complete the square, which is all equal to negative 6. Okay. Now, pay attention, please. This is a really important part. In order to complete the square, a has to be equal to 1. Is a equal to 1 right now? No, it's equal to 7. Usually we would factor this out or divide by a. Okay? In this case, we're going to factor it out. We're going to see if 7 goes into 112. So from this binomial here, I'm going to factor out a 7. Okay? Everyone's watching. This is really important. 7 times x squared is equal to 7x squared. 7 times 16x is equal to 112x. Then we're going to close parentheses, leaving a little space to complete the square. Then we're going to do the same thing here. Is a equal to 1 on the y's? No, it's equal to 17. We don't want it to be equal to 17, so we're going to factor out a 17 here, and hopefully it factors out a 102 also. So I'm going to factor out positive 17. I know that 17 times y squared is equal to 17y squared. And then 17 times positive 6y is equal to 102y. Okay? Bring down the equals to negative 6. Okay, so this is an important step. I'm going to put a star by that step. Okay? And actually I'll do a double star because here's the next star. Okay? Because it's super important. Now we're going to complete the square. Here's the second tricky part. Okay? Let's look at b. b is 16. Half of 16 is 8. 8 squared is 64. So I'm adding 64 on this little part right here. But not only am I adding 64, but I'm adding 64 times 7. Right? Because this 64 is being multiplied 7 times on this left side, so I'm distributing the 64 7 times. So I'm going to not only add 64, but I'm adding 64 times 7, which is we're adding 448 to both sides. Okay? Did y'all see that? Now half of b here, half of 6 is 3. 3 squared is positive 9. I'm not only adding 9 here, but I'm adding 9 times 17. What's 9 times 17? 9 times 17 is 153. Okay? So we just completed a square. So that's why that's a double star, okay? Because there's 2 steps there that are really super duper important. Now we're going to bring everything down with a factored form. These are both perfect square trinomials. So bring down your 7. Okay, square root of x, x squared is x. Half of 16 is 8. Okay, all squared. Plus, bring down the 17. Square root of y squared is y. Half of 6 is 3 squared, which is all equal to negative 6 plus 448 plus 153. You'd have to calculate that. You'd add them all together, and you get 595. Okay? Now at this point, so I'm going to backtrack a little bit. At this point, we're going to check our coefficients here. They're different, so I know that it's not a circle because you remember everything has to be perfectly round for it to be a circle, so it's not a circle. So this 595 needs to be equal to 1. Just like on problem number 1, we want to make sure this side's equal to 1. So we divide everything by that particular number. 595 divided by 595 is equal to 1. So whatever I do to one side, I do to every term on the opposite side. Okay? And now we have fractions here. What goes into both 7 and 595? 7 does. 7 divided by 7 is equal to, 595 divided by 595 is 1. What goes into both 17 and 595? 17 does. 17 goes into 595 35 times. 17 cancels itself out, so we're just left with y plus 3 squared. Then what goes into 7 and 595? 7 does. 7 goes into itself 1 time, so it cancels out. And it goes into 595 85 times, so bring down the x plus 8 squared. At this point, you could see it's in standard form, right? So we're done. Okay, we know that our center is negative 8. Let me erase this one. Our center is negative 8, negative 3. A squared is 85, B squared is 35, and we're done. It's an ellipse, major X, right? Questions? Yeah.
Why do you put is 8. And then 1 is 3.
Because we completed the square right here. This is a perfect square trinomial. If you were to do an x box, this is a perfect square, right? But we could assume these are perfect square trinomials. We don't have to do an x box. We just take the square root of x, bring it down. Half of 16 is positive 8. That's the trick here. You would have to do x box, but that's the trick, so you don't have to do the extra work. Same thing here. We're assuming this is a perfect square trinomial. Square root of y squared is y. Half of 6 is 3. Does that make sense? Okay, these are just the tricks you get to do when you understand the concept, okay? So that's how you complete the square to put it in a standard form. This is hard, and this is the hardest part of the whole unit is doing this complete the square method, okay? Which we have to know how to do. So today is Tuesday. Let's have 2 silly ones first. 2s are talking first about number 1. Specifically, when you're talking 2s, please note why did we divide by 100 here? Okay, and then when they're done, explain the whole problem. 1 cell 2 is about this whole problem, and then emphasize why did I factor out a 7, and then why did I, when I added 64, why did I multiply by 7 to get 448? Okay, where do these two numbers come from? All right, 2's talking first. Ready, set, go. Number 3. Please write down number 3. We're going to do this one together. Number 3, we're doing this one together. So as I work, you're working it out alongside me. Write down the problem, please, to start with. Okay, so we got x squared plus 16y squared minus 144. Always the first step. What's always the first step? We want to move c over to the opposite side. C is negative 144, so we're going to add, do the opposite, add 144 to both sides. Okay, so we got x squared plus 16y squared. Organizing your x's and your y's into their own groups. Okay. Now we want to complete the square if they're not perfect squares. So are all the x's together? Yes or no? Are they a perfect square already? So do we need to complete the square? No. So x's are fine. What about the y's? Are all my y's together? Yes, they are. Do we need to complete the square then? No, because they're already a perfect square. So we're not going to complete the square here. We're all done with that. Now looking at here, look at our coefficients of x's and y's. Are they the same or different? They're different, right? So is it a circle? No. When they're different, it's not a circle. Okay, so how do I get this right side? Since it has to be an ellipse, how do I get this right side, the 144, to equal to 1? Good, divide by 144. So we're dividing both sides by 144. Each of my terms by 144. So we have x squared over 144. We're going to keep that the same. We're just going to bring down that. 144 divided by 144 is equal to 1. We can make our h and k x minus 0 squared over 144 plus 16 goes into 144. So we got y minus 0 squared all over positive 9. We're all done. Oh, sorry. That's it. That's how you do number 3. Okay? Raise your hand if you want to do another one like that one. Does it make sense? Okay, number 4. Let's go to number 5. Okay. Working on number 5 now. Write down number 5 for me. Not number 6, number 5. I'm going to hide number 6. Okay, what's the first step? Always turn your neighbor. Tell them what the first step is. What's the first step, everyone? Move all the constants over. We have to subtract 108. Good. So, subtracting 108 on both sides. Okay. When I subtract, what should I do on the left side while I'm rewriting it? Put all my like terms together. Okay, so we got 4x squared. And we have negative 48x. And then we're going to leave a little space to complete the square. Put all my y's together. There aren't any other y's. And then we got negative 108. Okay. Looking at my x's, turn your neighbor, tell them, are they all together? And if they are, ask your neighbor, is it a perfect square already? Okay, so are all my x's together? Yep. Is it a perfect square? Yes or no? No, it's not. So, in order to be a perfect or in order to complete the square now, is my a equal to 1? No. Okay, so can we factor out 4 out of my x terms?
Yes.
Yeah, so we're going to factor out a 4. 4 times x squared is equal to 4x squared. 4 times negative 4x, or I'm sorry, 4 times negative 12x is equal to negative 48x. Leave a little space to complete the square. Looking at my y's now, are my y's together?
Yes.
Is it a perfect square?
No. Yes.
Yep, what's the square root of 9y squared? 3y. Okay? So it is a perfect square. So do we need to complete the square? Nope. Continuing on, we're going to bring down the rest of the problem, negative 108. Okay? Now we need to complete the square on the parentheses for the x term. What's half of negative 12? Negative 6. Negative 6 squared is positive 36. Okay, I'm adding 36 here, but am I really adding 36 on the left-hand side? We have to multiply, right? It's being distributed 4 times, so it's 36 times 4, which is 144, correct. So we're going to add 144 to the right side. The y squared is already a perfect square, so we don't need to complete the square there. So bring down the 4, and then we could bring down the factored form, which is square root of x squared is x, half of negative 12 is 6. Okay, bring down the 9, and while I'm at it, I'm going to put, 9y squared. Negative 108 plus 144 is 36. Looking at my coefficients in front of the x and the y's, are they the same or different? They're different. Today they're all going to be different. Since they're different, we're going to assume it's an ellipse. So is 36, looking over here at 36, is it equal to 1? No. How do I get 36 equal to 1? Divide by 36, that's right. Okay. So now I start simplifying. We know 36 divided by 36 is equal to 1. And then we know that 4 goes into 36 and it goes into itself, so it cancels itself out. Goes into 36 9 times. So we got x minus 6 squared over 9. This is the first term. Second term, what goes into both 9 and 36? No, what goes into both of them? Think bigger. 9. Good. 9 divided by 9 cancels itself out. And 36 divided by 9 is 4. So y minus 0 squared over 4 is the second term. Can I do anything else on this problem? No. It's all of a sudden in standard form, right? So good. We're all done with number 5, okay? Okay. Any questions on this? This will get more familiar, easier to get through when you do more problems. Take examples of this. Okay, so I'm going to conclude the lesson there. Okay.